Welcome to Walkabout the Galaxy, the face-to-face astronomy podcast where the science is universal, the opinions are personal, and the hosts are delighted to be breathing each other's air.
Ooh. Is that ever true?
We are Strange, Charm, and Up the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. New hashtag shorts are coming to YouTube, where we'll see Upquark speaking in iambic pentameter, among other things.
Oh.
Yep.
It's coming.
Yep, because I am British and therefore I speak
Therefore
Shakespearean.
Exactly.
You do speak Shakespearean.
Mm-hmm.
And my dad was a Shakespearean scholar, so I write Shakespearean, and you'll read it. And it will be awesome.
My 11th grade high school teacher will be super proud.
Okay. We are also sort of at www.walkaboutthegalaxy.com, where you can also sort of see how to order a Walkabout shirt and support STEM education, but really what you should do is email us at wtg
That's what I heard.
at ucf.edu. Where did you hear that?
Down the grapevine, you know.
Cool.
Yeah.
I'm really thrilled we're on the grapevine. Our stumper today is omnipotence-ical.
Okay.
If you had the power to tweak...
Anything? Oh.
Not omniscientical, omnipotence-ical.
Okay.
Sickle.
It
Sounds
rolls
like an
off.
icicle.
I know,
It
it's a
rolls
popsicle.
It rolls off the tongue.
It is very warm out.
Omnipotence-ical.
So what are we doing? What do you want to know?
If you had the power to
Yeah.
tweak or change or add or delete a fundamental law of physics in the universe, what would it be and why?
I like the idea of deleting a law. That sounds fun.
I mean, I don't know. I mean, you are omnipotent in this stumper, so you could delete the strong force or something like that.
So one of the limiting factors in space travel is how fast we can go anywhere.
True.
Which is limited by speed of, well, I say it's limited by, but in the formula it's limited by the speed of light.
Fundamentally, yes, it's limited by the speed of light.
And so if
That's really what restricts us most of the time these days.
Yeah,
Yes.
it's the speed of light. So if the speed of light...
It took New Horizons 7 or 10 years to get to Pluto's damn speed of light.
If only light was faster. Well, because if that constant was bigger, then heavier things could travel faster. Because in order... our maximum speed that we can travel is limited.
Well, by the speed of light,
the speed of light ultimately.
Right, yeah.
So if we had a higher speed of light, then we can ultimately travel faster because we can only approach the speed of light, right? Well.
So you want the speed of light to be how much faster?
Whatever factor it takes for us to get to the nearest star.
Okay.
Because that would be cool. In a lifetime travel to our nearest star.
I feel like there's a flaw in this.
There's a lot of flaws in
this.
So
here's the thing. So if you are traveling close to the speed of light, whatever the speed of light is, you on the spaceship have...
Yeah, I feel like you want some sort of Newton's law change instead of a speed of light change. Is what you really want.
Yeah, because you're forgetting about time dilation.
Yeah.
I'm sorry, I didn't think this through entirely.
No, we're talking through it now.
Yeah.
We're figuring it out.
Let's find the flaws in my fundamental physics.
Because as you're traveling very close to the speed of light, then yourself, you don't notice that time taking so long to get there, right? All your friends will be dead, but
I'm at the nearest star, having the time of my life.
But you're at the nearest star, so you can still get to the nearest star even with a slow speed of light, as long as you're traveling close to it. I think the fundamental problem is how hard it is to get close to the speed of light.
I think you want something with F equals ma or something where
or maybe
traveling with things is easier.
Maybe you want E equals m times the square root of c or something like that,
right.
So that your energy doesn't have to go as or kinetic energy is 1/2.
What if you have Newton's law?
Or your kinetic energy is 6.
Yeah.
Just
get rid of the
fixed
1/2 mv squared. Your kinetic energy is just always 6.
Yeah.
I think. What about you, Addie?
Oh God, I don't know. I will say that there was a Jeopardy question the other day, and maybe it was a replay Jeopardy, but there was a Jeopardy question the other day about something about fundamental laws, and somebody answered it wrong. And this is a terrible story now, but it was really.
I will help you out on that story
it.
because
Okay.
I watched it, and I'm amazed at how much these people know,
and
how little they
know
know about
science.
Space and science.
Yeah.
Can I ask what channel is Jeopardy on? Because I've never seen it.
Locally, it's on ABC.
Okay.
Yeah, but I
Channel 9.
I can't believe these people are like so knowledgeable.
Yeah, about
and
so
then
many
there's
things
like
about
basic
like
question about
nuances
comets.
of literature.
There's this thing about
Oh my
comets.
God.
And it's like comets have two tails. One of them is called an ion tail. This other comet made of little tiny particles pushed away by the sun is called the blank.
And somebody said
what is asteroid? Somebody else goes, what's a galaxy? Or something.
Galaxy.
I mean,
it
wasn't that.
It's
But it was just
something like that, though.
Yeah.
Like it's dust.
Yeah.
Yeah, but what was it? It was Newton's. The answer was Newton's law, or it said anyway. It was really upsetting.
So the thing you would change about the universe is people's general knowledge of it.
That is a fundamental law of physics: is that people don't get it, right? I don't know.
It's a tough one because there are all these ramifications that trickle down.
Yeah,
and then you get berated for it when you.
No, we're not berating.
We're
not berating. We're trying to help and fix it to get what you want.
It's okay. It's okay.
Yeah, I think something about I want to say something with like Newton's laws to make. I
like the direction that we're all thinking about. We want to get to one of these other places faster. It doesn't even need to be the next star. Like I'd like to be able to get to Mars faster than 6 months.
Sure.
Right?
Like, things just need to not be conserved.
And so
as a general rule,
maybe conservation
break some conservation laws or something like
conservation laws.
Yeah.
Some of these theoretical like engines and spaceship designs you see definitely break some conservation laws. So I guess that's just what we need.
Yeah. Okay. Well, we'll work on it. We're gonna have to work the details out. It's like Jim's flat Earth model.
Pi equals 8RT. No.
8 pi
G equals.
G equals 8 pi RT. G equals 8 pi RT.
8 pi RT. New science.
And kinetic energy equals 6.
Kinetic KE equals 6, yeah.
So we'll work out the details along with Jim's flat Earth model, which I'm not sure if you're familiar with Jim's flat Earth model.
Do I want to be familiar with?
We all really want to be familiar with Jim's flat Earth model.
Probably including Jim.
He's been promising for years.
Yes, all we know is that it involves mirrors.
It would be fun to do something with one of Kepler's, like with Kepler's laws.
Changing those.
Change orbits or something. Yeah.
But I wouldn't call those fundamental.
Oh, okay, that's fair.
Okay,
that's fair.
They're coming from.
Okay.
They're coming from the general relativity or something like that. Ultimately, well, today we'll be talking about lightning.
I'll change lambda because who knows what it is.
Who knows? There you go. The cosmological constant.
Lightning.
Today we'll talk about lightning, the great galaxy controversy.
Uh-oh.
And the youngest planet ever seen. But first, this episode of Walkabout the Galaxy is brought to you by Bayesian statistics.
Oh, goody.
If you're tired of flipping...
This is heavy.
If you're tired of flipping coins and rolling dice and ready to move on from prior probability to posterior probability, and who isn't?
Oh, my.
Try Bayesian statistics. Allowing knowledge to inform your statistical arguments, Bayesian statistics lets you solve the Monty Hall problem and win a car. Take advantage of new information and leave your frequentist and classical probability interpretations behind and tackle problems from the multi-armed bandit to the shapes of celestial bodies based on limited occultation data. With Bayesian statistics, you may not get a car, but you're more likely to know if you will or not.
Okay.
Bayesian statistics. Luck has nothing to do with the games they play. And it does have something to do with whether or not you'll get this, because you won't.
Is it a gambling thing?
Well, yeah.
But that's all I've got.
That's about as close as you'll be able to get unless you have some divine inspiration. Addy-dove.
It has nothing to do with the games they play. World Poker Tour.
That's, I like that you picked something that isn't a product, because this also isn't a product.
Okay, it didn't seem like it would be.
It's the movie Casino from 1995.
Ah, it's a tagline. Movie tagline. We've entered a new realm.
I'm into movie taglines. Let's do those.
Exclusively?
No, just
occasionally.
dabble.
Yes. Okay. Well, this is. I don't think the first time we've dabbled in movie taglines, but in any event, there we go.
Okay.
Space news: the Super Heavy is
very heavy.
The some reason started to say SpaceX.
SpaceX.
SpaceX. The Super Heavy is on some kind of pad out there in Boca Chica, Texas, and they did some sort of limited hot fire, and they've announced new target dates for their orbital flight test of the range of September to March. September 22 to March 23.
Okay.
I'll get my ticket ready.
Yeah.
But
is that going to be from out here?
No, from
Boca
out
Chica?
there, from Texas.
Did they get the approval yet?
I don't know if they've gotten the full approval from FAA. But from out here, pad rollout is less than a week away for Artemis 1.
Y'all.
Currently targeting still August 29th.
I got
8:30 in the morning, which is not the greatest time of day for viewing here because we're going to be looking towards the rising sun.
Yeah. It'll already be up by then, but
still
it'll be low and
right there in the sky. It's not the best time of day.
Wow,
but
we're getting picky.
Talk about things to complain about.
I did get to go to the VAB yesterday and see SLS.
That's pretty amazing.
In the VAB. I hadn't been in the VAB in like a really long time. I think maybe since I was since I came
Space
down,
camp or
since
something.
I was working at Space Camp, and we came down and did a tour, which would have been in like 2000 and
the VAB, the Vehicle Assembly Building, is an awesome space.
It is. It was at one point. It was the largest building
by volume,
and it's still one of the tall. And
it's still the tallest door,
something like
in
that,
the world, or something like that.
It is a very
It's
impressive
space.
edifice to be in, and they build rockets in there. They assemble the rockets, and it's very impressive.
And we could see most of. I'll post a picture. I forgot to post a picture. But
so
we
you
could see most of
NASA's
SLS.
new big rocket.
I did.
Are you going to go to the launch?
I don't know. I may or may not be here.
Okay.
Right. Yeah. Let's see. The only other space news note I had was there were some new updates on how bad the climate is changing.
It's pretty bad.
It's badder than we thought. The Arctic is warming faster than we thought, even though we already knew it was warming faster than the rest of the
Is
planet.
this the tree thing?
This is an ice melting thing.
Because I've seen that trees are being found further
Yeah, I saw
north
that
than expected, a lot earlier than expected by like
hundreds of years earlier.
Yeah.
Oh, I didn't know about that.
Yeah,
No.
up in the Arctic.
This is partly related to positive feedback effect from melting ice. Ice is reflective, so it bounces energy-carrying solar photons back into space.
Can we have the positive feedback effect be a sponsor sometime and explain itself? Because it is not always very positive.
Yeah, it's pretty messed
this
up.
This is
very
This is something
name.
I spend a lot of time explaining
I
in my
know,
class.
yeah.
Positive feedback doesn't mean it's a good thing.
No.
When if I give you positive feedback, that's a good thing.
It still doesn't mean it's a good thing.
Anyway, okay, so let's talk about lightning.
Wait, I feel like there was another space news thing I was going to say.
Was it about lightning?
No, it was about...
Was it the Steve?
No, that's related to lightning.
Okay.
Anyway, I don't know. It was a space...
We can take a space news out of order.
That's true. If it comes back to me, I'll just
Spontaneous
shout it out.
space news.
Yes. Cool.
Okay.
Lightning.
We like talking about lightning.
Yes. And especially odd lightning.
And odd and fun atmospheric effects. And so it was a really exciting one.
You're very excited about this. Is a megajet, I believe they call
gigantic
it.
jet, megajet, something like that.
These ones that shoot up into the sky.
It goes upwards instead of downwards.
So lightning is basically, we've seen it. It's a spark, right? So it's a discharge between a positive thing and a negative thing, and when the amount of positive and negative gets so big that it says, I just can't stand it, I got to get together, the charge connects across that gap, and that ionizes the molecules in the interim, and you see this, it gets heated up, and you see this glowing lightning spark. And you can do it if you got a carpet and a metal doorknob, you can do it yourself, right? With
a smaller scale.
You can make a 1/4-inch lightning strike.
Yeah, you do it a lot of times on accident.
And yes.
If you don't live in Florida.
If you don't live in Florida, and if you live in Colorado, you do it a lot more.
I hadn't thought about that.
Yeah.
Yes,
It
the humidity.
here.
The humidity really prevents that big buildup of charge because the charge leaks through the humid air much more easily.
I did get a lot of electric shocks from getting out of my car when I went home.
Yeah.
Nevertheless.
And not here.
Not here.
So typically lightning is a discharge from within a cloud, between a blob of positive and negative, within a cloud or from one cloud to another, and then somewhat less often, but still pretty frequently between the cloud and the ground, where the cloud gets a big, due to friction of stuff in there, they build up a bunch of positives, and the ground is a nice source of electrons, and they spark between. This case, the ground is the ionosphere.
Yeah, the ground.
Meaning the electrical ground.
The electrical ground, yeah. So the thing that's at a lower potential is the ionosphere, because there's so much charge.
Way up there at...
build up.
However high up it is, but it's way up there.
It shoots 80 kilometers, 50 miles into the sky. Yeah. Grazing the low. Yeah, they're called gigantic jets, and they're very rare. They occur as few as 1,000 times per year, which is like, actually, there's a lot of lightning.
And then capturing that on camera as well.
Yes.
Yeah. And so one of the cool things is that they were able to, so there has been images that have been caught, like visible light images, but they've also, more recently, the paper came out that was studying it with radio waves, which makes sense because this is all EM stuff, and so you get really interesting emissions from the radio waves as it goes up into the ionosphere especially. And they found out that it moves a lot of energy, 300 coulombs of energy from the top of the cloud to the lower ionosphere. So that's like roughly 60 times a typical lightning bolt.
Right. So a coulomb is a measure of charge, and one electron has 10 to the minus 19 coulombs of charge. So you need 10 to the 19 electrons to get 1 coulomb. And this had 300 coulombs.
Yeah.
Yeah. So
a lot of energy.
A ginormous amount of charge sparking up to the edge of space. I mean, if you fly up to that altitude, somebody's going to give you astronaut wings. I can't remember who, but there is a group that gives you astronaut wings at 80 kilometers.
Yes.
The Air Force, I think.
I think the Air Force,
Isn't that cheating?
Oh, that's reading. Speaking...
I think your own rules, you know. Everybody, these are all just rules we've made up.
What is the Wild West? So what's next? What's our next story?
Well, I was going to shout. I remembered the thing I was going to say, which is that the Perseids are peaking tonight, this weekend, which is meteor shower, the Perseid meteor shower, which happens due to the Earth interacting with Comet Tempel-Tuttle or something, right? I think this one's Tempel-Tuttle, which is fun to say. Swift-Tuttle. It's Swift-Tuttle.
Okay.
Anyway, but it's also a fullish moon, so it's not great for observing because the moon's pretty bright.
And you guys love the moon so much.
I do love the moon, but we see it plenty. We don't see meteor showers.
So the meteor shower is when the Earth goes through the orbital path of this comet. Yeah. The comet isn't there, but it's left cookie crumbs.
Yeah, so because it's gone through this many times, right? And it's always shedding stuff.
Cookie crumbs.
Leaving cookie crumbs in its trail. Yeah.
Yeah.
We're watching falling cookie crumbs.
And so when we go blasting through it, and they're sort of the size, most of the things that we see when you see a meteor, for a meteor shower, are produced by things that are about the size of cookie crumbs, sort of centimeter scale bits of ice and stuff burning up in the atmosphere.
Yeah. There's some cool, speaking of the moon, there's like LDEX and some of the LRO observations, the things that have orbited the moon have interesting observations of like the dust and the debris that happens also when the moon, because the moon at the same time is passing through these dust clouds. So you can see, we actually see interesting observations that correlate with meteor showers on Earth too.
I did not know that. Cool. That is pretty interesting because for most of our observation of it is due to its interaction with the atmosphere, very different with no atmosphere. Well, before we get to the great galaxy controversy. Hannah, because our trivia is lightning based, I'm going to drop the trivia on you now.
Okay.
To contemplate.
Hopefully we won't have any blockage. I was reading that article and it talked about how they still don't really know why it goes up instead of down entirely, but there might be some sort of blockage on the underside of the cloud.
I've experienced that. It's not pleasant.
No. You don't want it to go up instead.
You don't want it to go up instead of down.
Yes.
Trivia, lightning. Yes. you mentioned 1,000 of these gigantic jets or mega jets or whatever that go up. Gigantic jets. I want them to be mega jets.
Sorry.
I really want them to be
come
mega
up with something
jets.
else that's mega. You'd need like 100 times more energy, right, for it to be a mega jet?
I guess.
I don't know.
Your first trivia, of course, it's multi-part lightning trivia. The first one is, what is the average number of lightning discharges per year on Earth?
Wow.
I'll give you multiple choice.
Okay.
And I've rounded to the nearest order of magnitude.
Okay.
100,000,
Okay.
10 million, 100 million, 1 billion, and 10 billion.
1 billion.
Your follow-up, you do not have multiple choice, so I'll just
Okay.
let you know what your bonus trivia questions are. What in physical scale, kilometers or miles, whichever you prefer, is the longest lightning bolt that has been observed?
Ooh.
And what is the longest duration of an observed lightning bolt?
Wow.
And finally, what is the location on Earth of the highest average lightning strikes per unit area? And what is that rate?
How
How big or small an area or whatever?
do you want? Do you want like the state of Florida, or do you want like Orlando?
More like Orlando.
Okay.
Yeah. Yeah.
Okay.
So,
Okay,
all right.
great.
So that's your lightning trivia. Now let's jump out into the realm.
Fittingly, it's now raining outside of the Walkabout Studios.
It is.
We're talking about lightning, but it's not lightning.
Not yet.
Not yet,
There is
although it is
plenty
that
of
time of
time.
year, right? Yeah. So the Great Galaxy Controversy. as I
Great
have dubbed
galaxy
it.
controversy, indeed. So
JWST.
people may have heard a lot of really cool, exciting news coming out of JWST as all of these images keep coming out and evidence of older and older galaxies. And now, just as a reminder, JWST is kind of pretty good at looking for old galaxies because it's searching in the infrared. And infrared, as the oldest galaxies are going to be further away from us, and over time their light is going to be stretched into the infrared. So JWST can find these infrared-looking galaxies.
Their light has been cosmologically redshifted right into the sweet spot for JWST.
JW.
Exactly, almost as if it was designed to do
To
so.
look at those
almost.
things. It is
What are the
just a
chances?
remarkable coincidence. Great good fortune.
Yeah, and so they've with this redshift, or with the infrared galaxies that they're finding, they're making some teams are making estimations for their age, which are some pretty record-breaking
Yeah.
early.
Yeah, we talked about like
galaxies.
most
One
distant,
last time.
oldest, young, or
Yeah.
galaxies from very early
Yeah.
in the history of the universe.
Like a few 100 million years after the
Big
Big
Bang.
Bang, which is by
Just the blink of an eye.
yeah, astronomical terms, that's pretty big, pretty young, sorry. But then some other teams have come into the mix and started questioning if this is actually true. Because this redshift phenomenon.
Classic scientist.
So this
questioning things.
this redshift of this light being stretched over time can also look very similar to the infrared of galaxies that have got a lot of dust in them. So if you have a lot of dust present, then it can basically absorb the shorter wavelengths of light, which means that only the infrared is being emitted.
Right. Plus that means, yeah. So is it, maybe it's both of these, but dust blocks the visible light.
Mm-hmm.
It also then is warm
It emits
and radiates infrared.
Exactly. So this dust can emit infrared as well. And so some teams have been using other telescopes to try and see if these very early galaxies in fact have dust present, and actually suggesting a much more average galaxy formation age of on the scale of billions rather than millions of years.
So this controversy should be solvable, right? I mean, this is we have the ability to make the observations that would distinguish, I would think, between are we seeing this infrared galaxy because it's cosmologically redshifted into the infrared, or are we seeing thermal emission from dust?
Yes.
That's my
techniques
naive
are, I think there are, but I forget what because as I'm not an astronomer, I don't know what technique they will use.
You're not an astronomer.
I'm not an astronomer.
Get out of here.
I know. I'm basically Moon Girl and limited in all other knowledge.
We had Moon Girl, we had Gravity Guy, and Electromagnetism Woman.
Mm-hmm.
Doesn't quite roll off the tongue, that one.
That's what it is.
Yeah.
Okay, but so I mean the telltale signature of the cosmological redshift is if you see the spectrum of a known thing, like you see the spectrum of hydrogen, you see Lyman alpha and the other lines, and you see that pattern.
Yeah.
That everything gets shifted the same amount. If you're just looking at a bright infrared blob, you really don't know what you're looking at. So you need to have spectral information.
And that's exactly what's coming from JWST, which I did. Yeah, I do remember this now. So they're waiting for the spectroscopic measurement to see. Moon Girl messes up again. However, there's also there's two teams that are questioning these galaxy
I'm sure
ages.
there's more.
There's probably more. These are the only ones that are about to be published. And another one they found in what looks like a galaxy cluster, where the other galaxies in that cluster are much younger.
Bluer looking,
yes.
less infrared-y.
Which suggests that this one with this redshift is potentially
just dusty and not
rather
really
than
right.
this random old galaxy.
Well, this is, I mean, this will get sorted, as they say.
It will, but it's great watching scientists
sort it out.
Sort it out.
Yeah.
Yeah.
Well, argue.
I mean, I'm sure, are there any profanities in this argument?
There may have been behind closed doors, but
does
not.
it sound like
me ranting about a sandwich?
Coming to you soon on our shorts.
Right. Addie's experience with ordering a sub.
Yeah.
But that's one of the sort of classic things that we're always dealing with, right, is that it's this big exciting thing when this big telescope gets launched and takes its first measurements and everyone's like, what's the answer? And it's like, it's going to take us some time to figure out what the answer is,
Which
right?
is why I'm confused why there are these publications coming out. It's as if they just want to get the publication out as soon as possible instead of waiting for, like, the answer might come soon. I don't know.
The thing is that if you take a look at the publications, they are generally, if you read the conclusions of the publications, what they're putting out there is the data.
Yeah.
Right? They're saying, we took these observations, here are the observations, and
here is an interpretation.
And here is one possible interpretation, and frequently they're going to say, but
and also
it
a
could
lot
also
of
be due to this, that, or the other. Additional observations are needed to determine this, that, or the other. Yeah. We had several episodes a couple of years ago about the potential detection of phosphine
in
the
Venus.
atmosphere of Venus. Mm-hmm. And you don't really hear much about that anymore. Yeah. And the original paper said, we see this signal. Here's what the data look like. This looks like phosphine to us. We don't know how phosphine could be there. One of the things that produces phosphine is life, so it gets a lot of publicity. Then the fact that it was published then enables lots of people to take a look at
that's
and
true.
say, hey, you know what? There's something about your data interpretation. I'm not really sure you're seeing phosphine there.
Yeah.
And
so, like, for that paper, actually, it was a question of, like, how did this make it through peer review?
Well,
in some ways, but for other papers, it's like, this is one possible interpretation, but maybe there are others.
Yeah, I mean, part of the way part of the way the scientific process works is, at some point, it's like, I did the best I could do. Here's what I think. I share it with the world, and then sometimes the world comes back and says, "Oh, you know what? You forgot to carry the 3."
Yeah.
And if you do that, then you're like, "Oh, shoot."
That's why we just do experiments that always have sketchy results.
Right. So
inconclusive results.
So I think it's good they're publishing all that stuff.
Yeah.
And but it will take time for everything to get sorted out. Yeah.
Astronomy takes time.
Yeah. Speaking of time, the other story I wanted to talk about, sort of deep spacey, but within our own galaxy, is coming from a different telescope.
ALMA.
Which is the Atacama Large Millimeter Array, I believe.
Interesting. I would say Atacama.
Oh, man. I mispronounce all these things, probably.
I don't know if I'm right.
Jim is always getting on my case for the LHC.
We'll get some angry comments from him on the channel.
In any event,
he won't listen.
This also looks in the longer wavelengths of light. and it's it's an array of telescopes.
We like talking about ALMA because it makes protoplanetary disk observations,
which we're very fond
which
of.
we like.
And it kind of blows my mind because when I was a kid, like you guys are, we had these models and computer simulations of like what a forming planetary system would look like. And this thing is taking pictures, actual pictures of them. And
that is cool.
You know, you can see the spirals, you can see these disks, and you can see the gaps in the disks. And it's very cool.
And often the gaps in the disks are created by planets that form and clear out the dust around them, just like a planet should by the definition.
And like in Saturn's rings, you know, where you've got these.
That's exactly right.
These little clumps that clear out their rings.
And so in this particular case, they're looking at a very young star. It's called a T Tauri star.
Oh, okay.
And that's a T Tauri is the name of an individual star that's now got a whole class of stars named after it.
Like Pluto.
Yeah.
The Plutinos, which is also a good band name.
Yeah.
Pluto and the Plutinos.
This star is a few hundred, do I have that right, or a few thousand light years away, but it's in our own galaxy here in the Milky Way. And they're looking at emission from the carbon monoxide molecule in the gas of this cloud. And I think it's a pretty cool bit of data analysis they did because they're looking at the distribution of that stuff. And so we see this nice double ringed structure around the star, which is pretty big. Right, so we're not...
Something like 200 AU or something.
Yeah, so kind of out to our own Kuiper belt.
Yeah.
Pluto is at 40 AU on average. We've seen things that have an average orbit size that's in the hundreds of AU. So it's pretty big, and it has a couple of, I don't know, if you either say it's a disk with a couple of gaps or it's a couple of rings, either way. But they're also able to look at the speed of the stuff in that disk, and by looking at the Doppler shift of the lines from this carbon monoxide emission, and the combination of like where the stuff is.
And they're using different isotopes of carbon too. They use like carbon-12 and carbon-13 in different parts of the observation, which is pretty interesting because they'll have slightly different wavelengths anyway.
Yeah, and so they're able to see that there's something accelerating or decelerating stuff in a particular part of that ring.
Yeah.
So we can't like see a planet in there. We don't have that resolution, but they've seen a blob.
A velocity kink.
Yeah, I saw.
There's a kink in the velocity.
That sounds very Back to the Future.
The kink sounds like, you know, something that's crawling around in your garage or something like, hey, get out here, there's a kink in the garage.
There's a kink in the velocity.
So yeah, there's a kink in the distribution of the speed of these molecules moving around in there, which is consistent with a blob of mass.
Yeah.
And our ideas about how planets form in this
blobby.
disk, there's a blobby aspect to it.
Yeah.
So you start making a concentration of mass in the disk, and that opens up a gap, and we see gaps right in the disk. But still material feeds into it through these channels on the inside and outside across the gap into the thing, and then that makes a circumplanetary disk.
Oh.
A CPD.
CPDs.
And within that circumplanetary disk is where you get lovely things like moons and rings.
Yeah.
Right? And so they think that what they're seeing here is a circumplanetary disk around the star, and what's remarkable about it, beyond just the fact that they can see it at all and measure it, is it's very, very young.
It's gotta be young.
It's around a brand spanking new baby star, and this would be the formation of a pretty big planet out there. So it's a
I'd love to see this, just like imagery, like that would be amazing.
I know. And so we're talking on the ones of millions of years here for the age of this thing.
Planet.
And that's a really important constraint.
It's hard.
Yeah, it's such a
on
snapshot
planet
in
formation.
time.
Yeah.
Because it says, okay, thus the whole star formation, planet formation process is gearing up and producing a big planet type thing. And this is a star that's very similar, or will be very similar to the sun in 4 or 5 billion years. It's about the same mass as the sun. Yeah. And when we change the speed of light for you, Hannah, you'll be able to go there in just like that. So yeah, that's pretty cool.
That is a cool story.
It's sort of a
like
Jupiter-ish sizey planet, much further away from the star than Jupiter is from our sun.
Yeah,
but
it's closer to like where Pluto is or something, right? Or is it even further than that? I don't remember.
And so
anyway,
this is suggesting, this thing could possibly be forming through a different mechanism than we think the planets in our own solar system formed. We have this model called core accretion where it's basically it's like Legos, you put the parts together and get bigger and bigger and bigger. But there's another model that's sort of like, it's called a gravitational instability model, where you plunk together, everything plumps together all at once and make a big planet out of the gas. So obviously that goes quickly. And so this may be what's going on in this particular case. So I thought that was cool.
Fun.
Yeah. All right.
Fun little baby planet.
Ready to tackle your lightning trivia?
Sure.
Are you ready for some stab in the dark answers?
Yeah. Just like the lightning bolts.
Yeah.
There'll be stabs in the dark.
Yeah. I did. We had one other little space news bit about Betelgeuse.
Oh yeah, Betelgeuse update.
Betelgeuse.
Yes.
I think so. The update is just that there's been some more recent observations of Betelgeuse that show that it's so Betelgeuse has been a periodic star with a well-known periodicity for a long time.
Very reliable.
Very reliable. Good old Betelgeuse. Mm-hmm. But somebody said its name too many times apparently.
And he got mad.
And now it's actually not going at that same. It's like 400-day pulsation rate is gone. It doesn't have the same pulsation rate, and this tracks back to what we've talked about before, which was it had that big. There was the big dimming event, which was maybe it was going to go.
We were all hoping,
but it didn't.
We were hoping,
but it maybe did burp out a lot of material. It had a big, massive eruption event.
Right, things went up instead of down.
It was like a little dramatic, a little mini surface nova.
Poor Betelgeuse.
Poor Betelgeuse. It had a bad situation.
It was like, I hope this goes down. I hope this goes down, but it went up.
It had some blockage apparently.
Yeah.
Anyway, so I think we've talked about this. So we think there was some sort of event that had this burpage,
a gigantic,
and it created a cloud of material that then sort of persisted around the star, which was what actually created the dimming.
Shadowing it or something.
Yeah.
And
but so they have some new observations from Hubble and a bunch of other observatories of sort of the behavior of Betelgeuse in the last couple of years. And so
they're putting
together a bigger story about what happened and what that's going to tell us about some of these stars like this that have
giant unstable
lifetimes maybe.
Yeah, so it's like a giant. The sun has coronal mass ejections, and this was just a ginormous one of those.
Yeah,
you said the Betelgeuse SME blasted off 400 billion times as much mass as a typical CME.
The 400 billion times more stuff than the sun typically belches when it has a belching event.
Which is good because a typical CME would be real bad, or is already bad news for us sometimes if it comes at the Earth. So imagine Betelgeuse throwing a lot
400
billion times more.
That is very dramatic.
Bad news for us. Our satellites would not do well.
No.
That's not the only thing that would do well.
It might end SpaceX though.
What is the average number of lightning discharges per year on Earth? Is it 100,000, 10 million, 100 million, 1 billion, or 10 billion? And I've rounded to the nearest order of magnitude.
Billion.
100 million.
It is 1 billion. 1.4 billion, actually, or 44 times per second on the planet.
There was one in the last 30 seconds here. Just heard the thunder.
Predominantly over land in the tropics because it's driven by friction of cloud formation. So you get a lot of that over land. There's some other interesting things about why you don't see as much lightning over the ocean. It has to do with salt sea spray, which is interesting. We'll talk about another time.
Okay.
What is the longest observed lightning bolt? So most of them are actually sort of within a cloud or cloud to cloud.
Yeah, but the gigantic jet
went up 30, 40 miles or something like that. Cloud to ground is sort of limited by how high clouds are, which is like 10
The
miles or
ground.
something.
Yeah.
So this is not one of those, right? It's within a cloud. It's breaking that record, right?
Oh, so like horizontal.
Yeah.
Yeah.
Oh, that could be 10 seconds.
Oh, we are doing that one. That's the third question, but the second question is
Distance.
kilometers.
Physical
Oh.
distance.
3 miles.
3 miles. I just told you that it's more than the distance from.
Oh, more. Oh, I
a
did. I missed that.
Cloud.
I missed that.
You could just walk
30
outside.
miles.
You could just walk outside here, and you'll see one going that's more than
Are we
3
doing
miles.
miles or
Hannah.
kilometers?
You can do either
Either
you
one.
want.
I'm gonna go 100 miles.
What's that in kilometers? I know what it is in kilometers. That's 160 kilometers.
Oh,
What
yeah,
do
I
you
do
say,
know that.
Hannah?
200 miles.
Oh,
That's 320 kilometers. You're both under 768
whoa.
on April 29th, 2020 in the southern U.S.
768 miles?
That kilometers, so like
Oh.
500 miles.
Okay.
60 kilometers longer than a Brazilian bolt a couple
Oh
of
my.
years before that. Jeez.
I don't know why I had that reaction.
I don't know why you did
A
either.
Brazilian bolt just sounds very exotic.
Yes. So yeah, quite long, and that's probably a sort of domino effect. These are probably cascading
Yeah.
arcs or discharges.
Yeah, it
long-
wasn't
in a
2
single-
charges 500
miles apart
Yeah.
that are sparking simultaneously across, which gets to the next question, which is how long, what's the duration of the longest continuous flash observed? And you can stick with your 10 seconds
yeah, I
if you
do.
want. Addie stumped.
30 seconds.
Right in the middle, 17 seconds.
Okay.
Yeah, pretty good. I don't know what I would have guessed, but I was surprised to see it was that long.
Yeah.
And we do live, we've talked about it, and sometimes on the
We
show
do.
we hear the thunder outside the Walkabout studio.
We do.
We do live in what's called Lightning Alley here, from sort of across the peninsula of Florida, because by jutting out into a tropical sea,
give
we
ourselves-
have everything, all the great ingredients, humidity and convection and land,
Yay.
to produce lots of
It was
lightning.
terrifying relocating here whilst landing and seeing lightning outside my window on
yeah.
the plane.
Yeah.
And just
Nice.
thinking, what have I
What's
done?
going
Welcome
on
to
here?
Florida.
It was Friday the 13th. I was like, this
Oh.
is a
There's
a-
definitely
a
more
horror film.
lightning here than there is in England.
Oh,
for
plenty.
Sure.
Yeah.
But what is the location? Is it Florida? Of the area with the most lightning strikes per unit area, on average over a year. So not instantaneous, like some
Yeah.
places may have more in July or whatever,
Yeah,
but
yeah,
averaged over a year. And what is that rate?
So
You
somewhere in Florida is one of the highest, and it's like somewhere in Florida.
Mhm.
I don't know names of places. I
Have you heard of like Europe? You can start big and narrow it down if you want. You want to tell me what part of the world you think it's in?
South America.
There's also a place in Africa, I think.
It is in Africa.
Yeah.
See, I literally this is just wild
it's-
guessing.
It's gonna be tropical
It is.
Africa.
That's right. Okay.
How
so
about that?
I'll take
Tropical
it.
Africa.
It's in the Republic of Congo, a village called
Hmm.
Kifuka.
A village.
This is based on some outdated data,
Okay.
and so, take this with a grain of salt,
Sure.
a spray of sea
Spray of
salt.
sea salt.
Mhm.
It's in a mountainous region, so that helps it make its electrical connections to the sky. I was surprised the rate was lower than I would have guessed.
Okay.
But just throughout the year.
Per square kilometer, what's
What's
the
average
number?
rate?
What's the total number in a year, average number per year in a square kilometer there?
Oh, I don't know.
158
Oh.
only, which I was like, what? That's the most?
That seems really low.
But a square kilometre is not very big.
That's the
That's
thing.
true.
A square kilometer isn't very big.
Yeah.
Yeah. So Lightning Alley, where we are in Florida, is one of like the top 5
Yeah.
places, and in the summer it is peaking at a higher rate than
I
some of these other
remember
places.
looking at all this stuff when we were working on our radio antenna
issues. Yes. Yeah.
things. Like,
Yes.
we have a radio antenna on this roof.
Right. Yeah. There is a lake in Colombia that has a particular geography with wind and water and funneling past an inlet that produces a particular type of frequent
You should see the,
Some good
lightning
hand
the
gestures.
dancing that's
circulations.
occurring
It's
here.
very
Check out the
expressive.
YouTube for this
Yes,
episode.
yes, we'll have to do that on hashtag
We'll
shorts. Yeah.
we'll bookmark this moment in time on the channel.
While it may have felt like the longest lightning strike ever, it was just
That would be
another episode.
amazing. I
That
hope
would
it
be a
felt like
super
that.
efficient.
That'd be
feels
so
like-
energizing
Yeah.
and
It flew by.
illuminating.
That
I
episode
love
just
it.
flew by. If you like the show, write a review and give us 5 stars. If you didn't, that's really your business and nobody's really needs to know about it.
Yeah.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, hashtag shorts, and all of our music videos, which is just one at the moment, but I promise you another one is coming.
You keep saying that.
I'm really excited about it, but
Okay.
I'm probably the only one who's really going to like it.
Well, great.
But-
I'm glad you've been hyping it for a year then.
Catch up on old episodes wherever you get your podcast. Follow us on Twitter.
At walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance provided by Logan Basinger. Thanks to our listeners in British Columbia and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astrocorks signing off until the next episode of Walkabout the Galaxy.
Perseids. Betelgeuse.
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 It recorded the whole time.
The whole
Amazing.
video? Great success.